Okay, as I told you, in each week I want to introduce one application of CNN in image classification. For this week I want to use CNN to classifying different facial expression. So for example, I have a data set with 7 different facial expression: angry, disgust, fear, happy, neutral, and sad and surprised. As you can see, in each of them I have several facial expression of different subjects. 3 sample images from subject 1, and here 3 samples of subject 2. And as you can see, all of them are very similar. In this data set, the subjects are Asian and the background is completely the same, and all of the images are taken in frontal view, and it is completely a challenging task to recognize the facial expression. Let me open some of them for you. These are the angry faces, for example. In the other folder, happy, for example. From the same subject, we have another facial expression, happy. 4 samples of happy. So we want to create a model on computer to recognize facial expression of a given test sample. So when I give it one test sample, the output of the model will be the prediction of the facial expression of that person, angry or other type of the expression that we have, sad, surprise. So I have a data set. It includes several images, and each image has a truth label. I know that, for example, this is an angry face. So we know the truth label of each image. Someone tell me that this is the happy face of the subject. This additional information, also known as annotation data, which is necessary for all of the supervised machine learning algorithms. In order to read all of this data in the Matlab, also load their truth label, we can organize them as different folders in the computer. So as you can see, in my dataset folder, I have some subfolders, each one named as one of the different facial expression categories: angry, happy, sad, and other ones. And inside each of them, I put the corresponding data. This is the way that we organize our data set in the computer, or read them as a image data store in Matlab, and use these folder names as the label. So by this way I can easily load all of the data in the memory and also assign each one a label. Let me show you in Matlab. So what is the path of this data set? So image data store is a data structure that can use to load a data set into the computer and also load their associated label. as you can see here, there is a parameter that I said label source will be folder names. Let me only run this command here to see what will be happen. Now as you can see in the workspace, I have a variable imds, the name that I give it to my image data store. Let's see what we have inside it. As you can see, image imds is an image data store with these properties. There is one property as files, another one is label, and some other ones which are not important for me. So as you can see, all of the 213 images that I have in the dataset, all of their paths are added to the files properties of this image data store. So actually we didn't load all of them in the memory, only their path is now available in the files properties. For example, check it, imds dot files. All of the images that I have are here, but not the actual image, their path. So I can load them if I need. So in the image data store, we have the path of all of the images that I have in the database or data set. And if you want to access one of them, I think we should use parentheses. So image data store file number 1 is this one. If I want to display it on the screen, I can use imRead function and read this image. Now the image, sorry, I will have to access this cell array. So for cell array, we want to we should use curly braces, not parentheses, because I want to use this content. So curly braces 1. Now as you can see, one image from the data set is actually loaded into memory, and here you can see that the number of rows and columns, it's an 256 by 256 image. This is the resolution, and this is the type, unsigned integer 8-bit. So it means that every pixel in the image has an intensity value between 0 to 255. Let me show you the content of this variable by double click on it. You can see the content of this variable here. So these numbers are the intensity values of the image. If it is 0, it means that it is black, 255 means white, and numbers between these two numbers are the value of the grayscale. So as you can see, we have different grayscale value between 0 to 205 for different pixels of the image. Let me display the image. If you want to display an image, we have imShow function. We should pass the name of the image variable. So as you can see, one of the image is displayed here. If I want to display the label of this image, is it angry or surprise or any other one, I don't know, we can check the corresponding properties of the IMDS. Let's check it. IMDS, we have files properties and labels. So let's check the label of this one. IMDS point label index 1. So label index 1 is angry. So this image is an angry image. By this way we can read one image and actually display one of the image of the dataset and also access to the corresponding truth label. Here I display 20 randomly selected images from this database. So here in line 11, random permutation create a random number between 1 to this number 213. How many numbers you want? I mentioned 20. So 20 numbers between 1 to 213 will be created. Let me show you the output of this function. Sorry. As you can see, there are 20 numbers and the numbers are between 1 to 213. So if I use this number instead of this value of the I that I mentioned here, instead of this 1, if I use this number, I can select different samples of the dataset. So I give them here in the permutation variable. So permutation is an array or vector with 20 size. Let me run it. Let's show you. As you can see, permutation is a vector 1 by 20 and it contains some double value. Now, by using a for loop in Matlab, for I start from 1 column 20. It means that start from 1 till 20. I use subplot function. Subplot create a figure with, for example, here 4 rows and 5 columns. So we have a figure. Let me show you. This is one figure, but by subplot I can divide it into different subfigures and display in each of them different images. So instead of display one figure, one image in each figure, I can create a figure which includes multiple images. So this is the number of rows, number of columns. So we have 4 rows, 5 columns, and then you should select one of them. These 4 by 5 images, let me first display it, then explain it on the image. Okay. As you can see, we have 4 images, 4 rows and 5 images in each row. And as you can see, this image, this section of the image consider as 1, 2, 3, 4, 5, then this is 6, 7, 8, 9, 10 till 20. So here this parameter, this I, tell the system which subplot or which patch or segment should be selected. Each patch or segment numbered between 1 to 20. So I use I as the value here to mention that which of these locations should be selected. So the first image will be displayed in this position, the second one, third, fourth, fifth, and then we come here 6, 7, 8, 9. So they are numbered in the subplot from 1 to, in this example, 20. Also, as you can see, I display their label by using title command. For each image I can show a title. So now you can see that this is a sample of angry facial expression, this is a sad, this is the fear, surprise, angry, and the other ones. Yes, here. So this is the part that I display some of the images, and we find out that how we can access them, how we can also display their label. So now in the IMDS or in my image data store, I have the path of the images and I have their truth labels. For all of the projects in this course, we will use the same idea for reading the data and access their truth label. So whenever you want to classify any other images, you should arrange them in your hard disk as different images in different folders. For example, let me show you another database that I have. For example, here, another facial expression dataset that I have is this one. They didn't give the different folders a string name. They mentioned 0 to 6. So we have 7 different facial expressions. Here we have, I think, angry images. But as you can see, these type of the images are more complicated than the previous one. We have different face angle and different background. So this type of the image, for example, this is a profile image. This is very harder than the previous data set in order to classify them. We will work on this one. In this one we have maybe sad image, and as you can see, the resolution of the image are very low, the size of the images are very small. Okay, let me continue. Do you have any question till this point?
Sir, are you going to provide the recording of this session?
Yes, I will put it in the YouTube channel and give you the link.
Okay, sir. Sir, as you were saying to me earlier that I need to practice Matlab and from the videos you previously uploaded. Are those videos on YouTube?
Yes, also I put their link in the LMS, I think. Let me check
yes,
it. I think
face recognition via Matlab.
Yes.
Part 1, part 2.
There are some elementary videos here. Also, I put one video about which one is CNN, object oriented, convolutional layer. Yes, we have deep learning and application video here, basic neurons. Oh no, these are the lecture notes that I recently added. Please watch them. and read them. These are the links of the different YouTube videos. Face recognition. These three ones are about the handcrafted feature descriptors, and these two are about the CNN. So watch all of them. You will get some basic idea about different methods for classification images.
Okay, sir. Got it. Sir, I think I should first watch some basic code videos for Matlab.
Actually, we didn't want to write code in Matlab. We only need the basic structures like maximum a for loop, if statement, and some basic functions. Most of the other parts are only some calling some functions. We don't need to write some complex code in MATLAB in this course. So in most of the case, you have to copy paste some code and only modify it. You don't need to write it from the beginning.
Okay, sir. Got it, sir.
Okay, let me come back here. So till this point, inside the workspace, you can see that I have a image data store which consists of all of the images that I have in my dataset and their truth label. Now I want to divide the dataset into two different subsets. Some part should be used for training and some part of the dataset should be used as the test set. So we want to split the image data store into two different subsets. For this purpose, we have a specific function, split each label. This function receives the name of the variable that you have the image data store inside it. In my case, IMDS. How percentage of this image data store should be used for training? It can be a number between 0 to 1 as the percentage. So in this example, I want 80% of the samples used for training and 20% for testing. How should I select this 80%? There is a parameter here, randomize. It means that each time that I run this program, select different 80% of the samples for training and the remaining 20% for testing. So by using the randomize, we give this ability to split each label to randomly select the data set into two subsections. As you know, in all of the machine learning, we want to train model, so we should give it some samples with the truth labels. And when we want to evaluate the performance of the system, we should give it some new samples which is not given to the system till this point, and all of them should be new for the system. So all of my images are here in IMDS. I split them, 80% of them inside the IMDS train and 20% will be inside IMDS validation. So let me run this line only. As you can see, there are two new image data store, one here IMDS train and one here on IMDS validation. Let me check them. As you can see, there are 171 samples inside the IMDS train, 80% of the dataset, and only 42 images inside the IMDS validation. So we will train the model by these images and then test it by these 42 images. We know the actual label of these 42 images. but the model also predicts a label. If the prediction label and the truth label is the same, then we say that this image is correctly classified. Otherwise, this is a misclassification. So the performance of the system will be the number of images that is classified correctly divided by the total number of images. By this way, we will find out the performance of the system. For example, if the performance is 90%, it means that in 90% of the times the prediction label and this truth label of each image is matched. Otherwise, in 10%, they are not matched, or the system cannot recognize or classify the test image correctly. For example, we give it an angry image, but the system predicted as a sad image or another class. If you need to know how much is the size of these two data set, we have a function size with return it. So as you can see, the number of samples in the image data store terrain is saved here, and the number of samples in the image validation is in the number of test image variable. In fact, as you can see, this function returns two numbers, 42 by 1. So I only want this one, 42. So I put this specific character here. It means that I don't care about the other parts, only keep the first one. I don't want to store it as a vector. When I write it in this way, the number of test image considered as a vector with two numbers, 42 and 1. But I want to only keep the first one, so I write it in this way. Now there are different ways to perform or construct a model. In this course we want to learn CNN. So as you know, CNN perform both feature extraction and classification together. In order to design a model by CNN, you should mention the number of layers and the size of the kernel and the number of kernel in each layer. So let me see how we can create a simple CNN. The first layer of the CNN is image input layer, and as you can see, the parameter is exactly the same as the size of the image that I have. One of the samples that I displayed is 256 by 256. So these number comes from the size of the image. And this one means that the images are grayscale. This is the first layer. The second layer is a two-dimensional convolutional layer. So convolutional 2D layer. There are different parameters. The first one is the kernel size. So as you know, we can have different size for kernel, 3 by 3, 5 by 5, 7 by 7. So we use 3 by 3 kernel size, and this is the number of feature maps that I want to extract in the first layer. 16 different feature maps. Adding same. This is another argument of the convolutional 2D layer function or layer. It means that add some zeros around the image in order to keep the size of the result as the size of the input layer. So do not reduce the size of the image. In the if you didn't put this one, after we apply a 3 by 3 filter over an image with 256 by 256, the result will be reduced by 2. so it becomes 254 by 254. So in order to have the same size as the original or input of this layer, in this example this number, we say that put some zeros around this image. You can see about the zero padding in the first video lecture that I upload in the LMS. After that we can have several different layers, but for now assume that we want only create a simple CNN. After we perform convolutional operation over the input layer, we should give it to the rectified linear unit. This is the nonlinear transformation that we should apply on the result of the convolutional layer. So ReLU layer is the next layer of the CNN, and then we will give it to the result of the ReLU will be given to the max pooling 2D layer. As I mentioned in the first video, we should perform subsampling on the feature that we extract here in order to reduce their size. One way is performing max pooling. So this max pooling means that reduce the size of the, or perform subsampling by factor 2. So the 256 by 256 become 128 by 128. So this is the kernel size for max pooling, and this is the number of pixels that each time I want to move the kernel to the right. 2 pixels. When I explain the layers, did you hear me?
Yes, sir, from max pooling.
From max pooling, okay. So the max pooling is used in order to reduce the size of the feature map that we extracted here. We want to perform downsampling, reduce the size of the features because it is very huge. So we don't need all of that features. We find the maximum between each 4 features in a neighborhood of 2 by 2 and keep that one only. So this is the size of the kernel for max pooling, and this is the number of pixels that we want to slide the kernel each time. So 2 pixels to the right, and when we reach to the end, 2 pixels to the down. Let me draw something here. So assume that this is the image and this is the kernel for max pooling. There are 4 pixels here. Between these 4 pixels we find one maximum and put it in the result. Then this 4 pixels should be slide to the right 4 pixels, 2 pixels, stride 2. Now between these 4 pixels we will find one maximum and put it here, and this will be a slide to the end. When we reach to the end, it come back here 2 pixels down from here, approximately this point, and again between these pixels we will find the maximum between each 4 pixels and put it here. So the size of the result will be divided by 2, something like this, for example. I explain it completely in the first video. Please watch it. So this is the main idea of the CNN. We perform some convolutional operation over the previous layer input. Then we perform rectified linear operation, and finally we give it to the max pooling to perform subsampling. We can perform it several times to extract more and more complex features. the first features that we extract here are very small and very elementary features. For example, edges or lines, orientation, or dot shape in the image. But when we give the result of this feature to the next one as the input, the next layer will combine these elementary features to each other and construct more and more complex features. So as you can see, these four lines or 3 lines are repeated here, and only we change these parameters. This is the number of features that we want to extract. So if you extract more and more features, the performance of your classification become better. But there is a restriction. When you want to extract more features, you need to give it a lot of samples. So since we have only a few samples in this database, I think we only, for the training, we have 100 something. Let me check it. How many images we have here for training? 171 images only. So this is not sufficient if you want to extract hundreds of features from this 170 images. So therefore I have to make the number of features here approximately less than 50 or 100, less than 64 or something like that. So the 16 can be 20, for example. Here this one can be 40. So you can play with these parameters to find the optimal setting, but for now assume that we have these 3 bunch of layers, and finally I have to give the extracted features to one classifier. So classifier in CNN is a softmax layer. So as you can see, the output of the last layer, the last feature extracted, will be given to a fully connected layer, and the number of neurons in the fully connected is exactly the same as the number of class labels. In the data set, this one, we have 7 class labels. So as you can see in the Matlab, here I put 7. It means that the last layer has 7 neurons, and each neuron is connected to all of the neurons of the previous layer. Fully connected means that each neuron of this layer is connected to all of the neurons of the previous one. Then we perform softmax operation over the result of this layer and perform classification on the last result. Let me explain it. So in the last layer we have 7 different neurons. Assume that these are the these are the 7 neurons of the fully connected, and each one is connected to all of the neurons of the previous layer. So this one is connected to the previous one, also this one. Each one is connected to every neurons in the previous layer. Now each one has some output value. we perform softmax over it. So in fact we compute the probability. So this is the neuron that indicates, for example, angry class. This is the sad class. This is the surprise class. So when we perform softmax over this result, for example, each one give me a number between 0 to 1, which can be considered as the probability that this test image belongs to this class, and the summation of these 7 values should be 1. So for example, as a result, now we have 0.3 here, 0.2 here, 0.1 here, and the other one is 0, for example. The output of the other neurons is 0. Now classifier layer check the result of this softmax and consider the maximum of them. In this example, this one. So the classifier said that this input image belongs to this one. So this is, for example, angry. So this input image belongs to the angry because it has the maximum value of the softmax. So in the end of every CNN, we have one fully connected, one or several are fully connected, but for this simple example, we have only one fully connected. Then softmax layer and classification layer. This perform some mathematical formula over the result of this fully connected to make it convert to the probability, and now we consider the maximum probability as the class label. So this is the way that we construct a CNN. So by playing with the number of layers, number of the size of the kernel, the number of features that we have, we can change the performance of the system, and we can tune it, we can adjust it to find the optimal setting. Now I want to train this model. I should mention some training options. So this is some parameters that we should perform. First of all, which type of learning algorithm you want to use. There are different type of the learning algorithm. So most of them are based on the deviation and backpropagation algorithm. SGDM is one of the famous one. There are several other type of the training algorithms. We have to mention the initial learning rate. It should be a small number, 0.1, 0.01. How many epochs you want to perform the training. In this example, 30. You know that we have, for example, in this example, it's 171 images in the training. When you want to train a model, each time that you gave all of the samples one time to the system is known as one epoch. So by this setting, it means that I want to feed these 171 images 30 times to my system to make it train completely. So we have to input every image several times. So each time some part of the information will be trained, some part of the model will be tuned, some weight will be changed, and after we give it several times, after a while the model will be converged to some stable weights, a stable situation, a status. shuffle every epoch. Then order that I want to insert this image can be shuffled every time. For example, first time I input image 1, 2, 3 till 171. The next epoch, the order that I want to insert this image are not the same as the previous one, so we will have some shuffle. Validation data will be we will use this image data store test part for the validation. So I give it this name here. So the performance will be test over this data set, these 41 images that 42 images that the system never seen it before. How many validation frequency is 3, so every 3 iteration I want to check the validation. Every 3 iteration the validation will be computed. If it is the frequency of the, if it is about the iteration, it should be a larger number, but if it is about the max epoch, I think 3 is okay. And plot the training process. So when I run the program, something like this will be plot, and you can see the way that the training progress during the different iterations perform, and the accuracy and loss function will be plotted here. But so here I ask the system to train the network. I should give it the training set, the name, the layers that I declared, and the training options. So these 3 parts that I declared here, layers and training set, this one, and the training object, training options are given to train network function, and by this way we produce or construct a model. I name the model as net. So this is my model. Let me compute till this point. Train a model in some cases takes a long time, and also you don't have GPU on your system like my computer, then it takes more time. Dataset contains only a few samples, so I will train this model my system, and I will record the video and show you the result. But for now, after we train a model and model successfully trained, we should check the performance, evaluate the performance of the model. For this purpose, we should give this model the test set, and the model give me the prediction for each of these samples. So y predict will be a vector contains 42 labels for the 42 different test samples that I give to the model. Now I have the prediction label for each image, and also I know the correct label of that one. Inside the labels properties of the image data store, I have the truth label. So this is the truth label, and this is the predicted label for each of the samples. Now I can compute the accuracy by this formula. Check these 2 vectors. The y predict is a vector, contains 42 values, and the y validation is also a vector with the same size. Check each of these 2 vectors one by one. If both of them have the same label, it means that we have one successfully classified and if they are not equal, it means that we incorrectly classified one image. So count how many position in these in these two vectors are the same. How many prediction is correctly performed. Sum them and divide it by the number of elements that we have. This formula give me the accuracy of the model. This is the correct classification, and this is the total number of images that we have in the test. So by this way we can find the accuracy and print it on the screen. So this is the general idea of using CNN for classifying some samples. In this project, we classified the facial expression into 7 different categories. If you check this video with the previous one that we perform face recognition, you will see that the general idea is completely the same. So this is one of the advantage of using CNN. We can use CNN in multiple situation. Face recognition, here facial expression recognition or classification. We can use it for, we will use in another video. I will show you how we can use it for animal classification.